We are going to find partial derivative of z equal to sine xy from first principle. So z equals sine xy, and we are to find partial z with respect to x. So I said that if z increases by change in z, that means x will also increase by change in x, because this is, we are differentiating z with respect to x, and therefore y is now kept as what? Constant. So we have sine x plus change in x, then we keep y as constant. So z plus change in z is equal to, if we expand this bracket, we have sine y times x equals x, y times change in x equals plus y change in x. So we have this. Now, from Greek identity, recall, from trigonometry, you have that sine a plus b is actually sine a cos b plus cos a sine z. From trigonometric identity, you have this. So if that's the case, it also means that sine x y plus y change in x is going to give us, this will give us sine x y cos y change in x plus cos xy sine y change in x. You have this from Greek identity. So if this is so, in place of this equation, in place of sine xy plus y change in x, I will simply put this value or substitute this. So I'm going to have that z plus change in z is now going to be, in place of this whole value, I will have sine x y cos y change in x minus cos xy sine y change in x. Okay. At this point, you send z over to this side of the equation. Send z over to this side of the equation. So we are left with change in z here to be equal to sine xy cos y change in x minus plus cos xy, this is plus please, plus cos xy sine y change in x minus z. Okay, so you have that. But recall that z is actually, from the equation, z is sine xy. Okay, so in place of z in this equation, we are going to have that change in z is equal to sine xy cos y change in x minus plus cos xy sine y change in x minus, in place of z is sine xy, so minus sine xy. So collect like terms together. There is sine xy here, there is sine xy here. Let's bring them together. So I will have that change in z is equal to sine xy cos y change in x minus sine xy plus cos xy sine y change in x. Okay, so sine xy and sine xy is common. So we have a change in z. If we factorize, we are going to have sine xy common, we have into cos y change in x minus 1 all over, plus cos xy sine y change in x. Okay, so at this point you divide all through or divide both sides by change in x. So I will have change in z divides change in x, and that equals to sine xy into cos y change in x minus 1 all over change in x plus cos xy sine y change in x all over change in x. Okay. At this point, you take the limit as change in x tends to 0 or the function change in z, change in x is equal to 10 to partial z, partial x. So that means now that partial z, partial x is actually the limit as change in x tends to 0 of the entire function. We have sine xy into cos y change in x minus 1 all over change in x, plus cos xy sine. So we can write this as change in xy, change in x, all over change in x. So if we break this limit individually, we are going to have partial derivative of z with respect to x is now going to give us, let's expand with the limits. We have limit as change in x tends to 0 of sine x y into cos y change in x minus 1 all over change in x plus limit as change in x tends to 0 of cos xy sine change in x y all over change in x. We'll have that. Okay, so I said at this point, let's bring that cos xy out behind the limit. So we're going to have that partial z, partial x is equal to limit as change in x tends to 0 of sine xy into cos y change in x minus 1 all over change in x plus, to bring out cos xy, we have cos xy limit as change in x tends to 0 of sine change in xy all over change in x. So you have that. Alright, so from L'Hopital's rule, recall from L'Hopital's rule, it says sine limit as change in x tends to 0, sine change in x over change in x is equal to 1. So in place of this function here, sine change in x over change in x, we'll simply replace it with 1. Okay, so we are going to have that partial z, partial x is now equal to, let's put in the limits. We say change in x tends to 0. So in place of change in x here, we simply put 0. So we have sine xy into cos 0 cos y times 0 minus 1 all over 0 in place of change in x, plus cos xy times. So we said that the limit has changed the x to 0 of sign, change the x by x is 1. So we have y that becomes 1 times y. So we have 1 times y. Okay. So we have partial z, partial x to be equal to, this is sine xy, y times 0 is 0, so you have cos 0 minus 1 all over 0 plus, this is cos, okay, 1 times y is y, so you simply have y cos xy. Okay, partial derivative of z with respect to x will give us sine xy cos 0 is 1 minus 1 all over 0 plus y cos xy. Okay, so partial x is now equal to sine xy, 1 minus 1 is 0, divided by 0, plus y cos xy. Okay, so partial x is now sine xy times 0 will give us 0 divides 0 plus y cos xy, and this is actually 0 plus y cos xy. So that simply implies that the partial derivative of that function c with respect to x is simply y cos xy.